Good afternoon. These are your notes for exponential transformations. These transformations are a lot like all the other transformations that we've done, where we're going to explore what happens when we change a, h, and k. Okay, the general form of an exponential is f of x equals ab to the x minus h plus k. So the first thing we want to do is look at the effect of h. So we're going to use y equals 3 to the x. And for my first domain, I'm going to use -1, 0, 1, and 2. So if I substitute -1 in, I get 1/3. 0 gives me 1. 1 is 3, and 2 is 9. So I'm going to graph those points. So -1, 1/3, 0, 1, 1, 3, and 2, 9. Remember, with exponentials, they are curved. They're as curved as you can get it. Okay. For the next one, my equation is y equals 3 to the x plus 2. Because it's plus 2, that means I had to put a -2 in there. So this should, if we do it right, shift left 2 units. Okay, so I'm going to use the domain -3, -2, -1, and 0. So if I substitute a -3 in, I'm going to get 1/3. If I substitute -2, I get 1, -1, I get 3, and 0, 9. Okay. So I'm going to go ahead and graph those. So I have -3, 1/3, -2, 1, -1, 3, and 0, 9. And again, and as you can see, every point went 2 to the left. Okay, for my next one, my equation is y equals 3 to the x minus 1, which means I substituted a positive 1 for my h. So using what we know, this should shift right 1 unit. Okay, for the domain this time, I'm going to use 0, 1, 2, and 3. So if I plug a 0 in for x, I'm going to get 1/3. If I plug 1 in, I get 1. If I put 2, I get 3, and 3 will give me 9. So I have 0, 1/3, 1, 1, 2, 3, and 3, 9. Okay, and you can see, again, all of my points shifted to the right 1 unit. So it says, how does h affect the graph of the equation? So when I have x plus h, it'll shift left h units. When I have x minus h, it's going to shift right h units. Okay, on the next page, we're going to explore the effect of k on our graph. So my equation is y equals 4 to the x. And I'm going to use the domain -1, 0, 1, 2. So if I substitute a -1 in, I get 1/4. 0, I would get 1. 1 gives me 4, and 2 gives me 16. So we're going to come down and graph that. So -1, 1/4, 0. Oh, and I messed up. I'm sorry. 0 is 1. Anything to the 0 power is always 1. 0, 1, 1, 4, and 2, 16. Okay. Okay. For my next graph, I added 2. So we changed the k to +2. And using what we know of the effective k, we should be able to predict that this is going to shift up 2 units. So I'm going to go ahead and use the same domain. So I'm going to do -1, 0, 1, and 2. So if I fill a -1 in there, I get 2 and 1/4. When I put 0 in, I get 3. If I plug a 1 in, I will get 6, and 2 gives me 18. So -1, 2 and 1/4, 0, 3, 1, 6, and 2, you kind of have to fake it, 18. Okay, and you can see my whole graph shifted up 2 units. Now, yesterday we talked about a new word. The word was asymptote, and it's the imaginary line that a graph comes close to but never hits. On my previous one, the asymptote was the same. It stayed at 0. Now that we've added a k, it's shifted. So let's keep that in mind, and let's look at the next one. It's y equals 4 to the x minus 1. And again, using what we know of k, we can make the prediction that this is going to shift down 1 unit. So my domain is going to be -1, 0, 1, and 2. When I substitute -1, I get -3/4. 0 is 0. 1 is 3, and 2 is 15. Okay, and I'm going to go ahead and graph those. So I have -1, -3/4, 0, 0, 1, 3, and 2, 15. Okay, and you can see again, my asymptote went down 1, and so did all of my points. Okay, so the effect, or how does k affect the graph of the equation? Okay, I've got 2 things. It will shift, or it shifts the graph up or down k units, and also k is the asymptote of the graph. All right. The last thing we need to explore is the effect of A. Okay, so my first graph is y equals 2 to the x. I'm going to use the domain -1, 0, 1, and 2. So if I plug a -1 in, I get 1/2. 0 gives me 1. 1 is 2, and 2 is 4. So I'm going to go ahead and graph that. Negative 1, 1/2, 0, 1, 1, 2, and 2, 4. And it would be 3, 8 if you want an extra point on there that's accurate. Okay. My next one is y equals 3 times 2 to the x. So I'm going to do negative 1, 0, 1, 2 as my domain again. So if I plug a negative 1 in, I get 3 halves. 0 is 3. Plugging 1 in gives me 6, and 2 is 12. So I'm down here and graph that. So negative 1, 3 halves, 0, 3, 1, 6, and 2, 12, which is not on here. So So it went up much faster, and we know that the A can give a vertical stretch or a vertical shrink. When it goes up quicker, that's a stretch. So this was a stretch by a factor of 3. Okay. My third one is y equals negative 2 to the x. And let's make a prediction based off what we know on A. If we do it correctly, when A is negative, it's a reflection over the x-axis. So I'm going to use the same domain, negative 1, 0, 1, and 2. So when I plug negative 1 in, I get negative 1/2. 0 is negative 1, 1 is negative 2, and 2 is negative 4. So let's graph it. Negative 1, negative 1/2, 0, negative 1, 1, negative 2, and 2, negative 4. And if you want to do 3, negative 8, just as a guide. Okay, and this is going to look just like our first one, but going down. It is the mirror image of our first graph. Okay, and our final graph is y equals 6 times 2 to the x. And we can make a prediction that this should be a stretch by a factor of 6. So my domain is negative 1, 0, 1, and 2. When I put negative 1 in, I get 3. For 0, I get 6. For 1, I get 12. And for 2, I get 24. Okay, so I'm going to go ahead and graph. Negative 1, 3, 0, 6. And then the rest is going to be off. Okay, so again, you can see none of these except for the negative did my asymptote change. And realistically it did, and it's still approaching 0. But it just stretched. If it were a shrink, would be a fraction. So the effect A has on the graph, if A is greater than 1, you get a stretch. If A is between 0 and 1, you get a shrink. And technically it's got to be it's greater than 0, less than 1. And if A is negative, you are going to get a reflect over the x-axis. You can find your homework for today's lesson either on my website as a download, or you can get it from either Miss Davis or I when you come back if you didn't get it. That's it. Everybody stay warm. Have a great night.